This is section 1.3 for college algebra. And we start off talking about functions and their representations, and this will follow us throughout the course. So the first thing to think about is when they talk about a relation of numbers, it's just a group. It has no parameters. It could be anything. But a function is a special relation where each x is paired with exactly one y, and that word exactly is crucial. So each x can only be paired with one y. And then we have this picture here talking about function notation. So y can be the same thing as f of x. X is your input, and then you call it f of x, g of x, h of x, whatever, and your output is the y values. So the set of input values are the x's, and that is your domain. The output is your range. So we talk about in the course a little bit about maps. And so I've drawn here some ovals. They're badly drawn ovals, but they're ovals. And in this, the left-hand side is x's, the right-hand side is y's. And there's connections between the x's and the y's. So this, if you were asked which one was a function and which one was not, you look to see, is there just one line coming out of each x? In this case, that's true. So that is a function. In this case, if we note that 3 has 2 lines coming out of it, so that means 3 is paired with 6 and with 7. That eliminates this from being a function. So that's one way to represent functions. The next way is just numerical. And if you think back, when you see numbers with parentheses and commas between the numbers, we should think about ordered pairs. And what we're looking for in this representation is whether x is repeated. So if we look at these, x is not repeated in this line. In this line, x is repeated. We have an x here, that's 3. We have a 3 here. And so 3 is paired with 4, 3 is paired with 9. Therefore, we don't have a function. So now let's look at another way of representation, and that is graphically. So I've got some grids here, and this purple line is our graph. And if you draw a vertical line through whatever graph you're looking at, you question, did I hit it more than one time? And with a line, we just hit it once right there. So that is a function. That's what that red check mark means. In this one, we have a parabola, and it really doesn't matter where I draw that vertical line. I'm only going to hit it once. And so that is also a function. But when we have this, which is a circle, if I draw it here and here, anywhere around here, I'm going to hit it at the top and I'm going to hit it at the bottom. So that is not a function. Have it better here. So you want to look, you draw a vertical line and see whether the vertical line hits your graph once or more than once. More than once makes it not a function. And the last way that we would look at them would be equations. And right now we don't have as much information as we will at the end of the course, but right now we're looking, if we have y equals 3x plus 5, and we know that the exponent on x is 1, that's going to be a straight line. So we already saw up here that that was a function, so we can say yes. Y equals x squared plus 2, the exponent on x is a 2, that's what that looks like. That's that parabola. Now we can't say that all parabolas are functions because a parabola can go this way, and that would be x equals y squared. But for all of the parabolas that are in the form y equals x squared, those will be functions. This last equation you may not be as familiar with, but this is the equation of a circle where you have an x squared and a y squared, and we have seen up here that is not a function. So this is 4 representations of a function, symbolically where you just have it written, f of x equals x squared plus 1. Numerically, that's those ordered pairs. And graphically, here we go, those points are plotted and you see that. And verbal, if you were reading it, f squares input x and then adds 1 to produce the output. That's kind of a lot of words, but it just means you square the input x, you add 1 to it, and that is your function. The other thing that we will be looking at in this section is evaluating functions. So if we're given something like f of x equals 8x minus 2, and you're asked to evaluate 3 different things, f of 2, f of a plus 3. So when whatever that means, f of something means take that and plug it in for x. So we're going to put that 2 right here, and we can do that distribution. We get 8 times 2 is 16, minus 2 is 14. We could do this one on the calculator, which we'll learn. We could find f of a number in a function on the calculator. But what if we were asked for f of a? We plug in a, and if we distribute that 8, we get 8a minus 2. That's all we can do, but we're still just plugging in. F of a plus 3 equals 8 times a plus 3. We're substituting for x, and then a minus 2. We distribute that 8. That gives us 8a plus 24 minus 2. And so we combine the 24 and the minus 2, and our final answer would be 8a plus 22. All right. Now one of the last things, we're going to skip that little graph right there. Domain is where the x can exist. Range is where y can exist. So keep that in mind as we go through any problems that talk about domain and range. Then I put this little chart. This is also in the handout called Yellow Packet, which has all the notes for the course. But this page is in that yellow packet. But right now I've put it here because you do need it for a little bit in this section. And so there's 2 different kinds of expressions for answers: inequality expression or interval notation. If you'll note, in the inequality, there is an x in the answer. Interval notation is either parentheses or brackets. There's numbers. There are no x's. And then the graph is simply that. It's on a number line. So let's talk about that a little bit. This one says, and you can just think of it this way, x falls between -2 and 2. If you read it, -2 is less than x is less than 2. But I think sometimes it's easier to just look at it and say x falls between those two. Over here in interval notation, the same answer, you just have parentheses, -2, comma 2. Same thing, x falls between those two numbers. Now, it's just less than, doesn't have an equal in it. The equal is when you get your bracket. So down here in the second one, x falls between -1 and 3, but 3 is included because there's an equals under there. So it could be less than 3, but it could also be equal to 3. So when we turn that into interval notation, we have parentheses, -1, comma 3, and then we have a bracket. You can see in this one, they both have equals in there, so we have brackets there. All right, x is greater than -3. That means you're going to start at -3 and go forever. So you start with a parentheses, -3, comma, you go to infinity. Infinity always gets a parentheses because you can't reach that. If we had x is less than or equal to 1, we know there's going to be a bracket, and it means x is going to be to the left of 1. If we go all the way left, we're at -infinity. So we have a parentheses, -infinity, we go to 1, we have a bracket. Sometimes you have 2 pieces. You have x is less than or equal to -2, or x is greater than 1. When we put that in interval notation, we have a u between it. And we have negative infinity to negative 2 with a bracket, or 1 to infinity and a parenthesis. If this one, x falls between negative infinity and infinity, that's the whole number line. That's all reals. And then here you just drop the x. You have negative infinity to infinity. And on the number line, it's the whole line. And you note that we have a bracket there. We have a parentheses here. So in the number line, those show up, the brackets and the parentheses. So that is that. And that's just showing the graph and the domain and range. So let's go look at the problems that are given to you for practice before you do your homework. Okay, here are the set of problems, and again, these are practice to prepare you for the homework. So number 1, write the inequality in interval notation. So you're just going from this form where 2 is less than or equal to x. So that tells you you start at 2, you go to x. Okay, I saw an error and had to fix it, but it is correct now. So this says we're starting at 2 and everything greater than 2, with 2 being included. So there is a bracket there, and then in parentheses at infinity. Number 2, x is less than 10 or x is greater than or equal to 13. So here we have it's greater than 10, so it's less than 10, sorry. We start with negative infinity, we go to 10, there's a parentheses, we have a u for the or, and then we have x is greater than or equal to 13. That means we'll have a bracket here for 13, and we go to infinity. On number 3, we're going from a graph to interval notation. So we note that we are between negative 6 and 9. We have a bracket here, a parentheses on the right. So this is what our answer will look like, negative 6 to 9, bracket, parentheses. Select the interval notation that's represented by the graph. Same thing. We start at 2 and go all the way to the left. That means we're going to start with negative infinity and go to 2. We have a parentheses because we do not have a bracket there. All right. Number 3 is a graphing question on the computer. So when it says use the graphing tool, you will, there's a place that says enlarge the graph. So I would enlarge the graph on your computer, and I would choose the line tool. And let's see if I can move this over a little bit. Can't quite see it in this palette, but there'll be a palette over here, and you'll choose the line, not the parabola or anything. And then you have to pick a couple of points to plot, and it's always easy to plug in 0, usually easy. So if I let x be 0, 3 times 0 is 0. So I have 0, 0. If x is 1, 3 times 1 is 3. So I'll plot those 2 points, and I will connect the line. And then that will be your graph. Same thing for number 6. And I'm not sure if you have to actually, I think you do have to do the plots the same way. But you're given f of x is equal to x plus 1. So you're going to plot 3 and a negative 3 and whatever f of negative 3 is. Plot 7, f of 7, plot 5, f of 5. So you're just plugging in those numbers into the given equation, and you get your y values. So the difference is you're not picking your x's. They give you the x's. You'll find your y's, and you will plot negative 3, negative 2, 7 and 8, 5 and 6, and when you get those 3, there will connect, and there will be your line. So number 7, you've got f of x is absolute value of negative 6x. Well, when you go into the tool palette, you'll choose the V for absolute value. And then you can still pick 2 two x values. So if x is 0, you're going to be at 0. If x is 1, negative 6 times 1 is negative 6, but the absolute value is 6. So you've got 1, 6, and if you did negative 1, you'd still be at 6. So you have those 2 points there, but it should graph at that point. All right, let's look at number 8. Write the function as a set of ordered pairs. Give the domain and range. So it says f of 1 is 9, f of 2 is negative 2, f of 3 is 3. Well, there you go. There's your x, there's your y. X, y, x, y. So I put them in parentheses and pay attention to the directions. It says type ordered pairs and use a comma to separate the answer. So if you don't have this comma, in other words, I left one out showing you. And right here, we need one, so that you would have to have that comma on there to make it be right. It would count it wrong if you don't have that. And then it asks for the domain, which is just the x values. So 1, 2, 3. And the range, so that I've got that there now. The range is 9, negative 2, 3. Commas between them. There's no parentheses on these answers. Okay. Number 9, find f of x for the indicated values of x if possible. So x cubed for x equals negative 1 and 4. So you're plugging in those two values. F of negative 1 is negative 1 cubed, which is still negative 1. Because negative 1 times negative 1 is a positive 1 times a negative 1 again gives you a negative 1. So there's our final answer. F of 4 is 4 cubed. That's equal to 64. And then it says, choose the correct thing. The domain is, this is if you have some restriction on the domain. All real numbers except for, nope, we have nothing. You can plug in anything for x here and it's valid. So the domain is all real numbers. Number 10. Same idea, but you are plugging in negative 1 and then a plus 7. Remember, we did that in the notes. So if f of negative 1, I'm plugging in negative 1 for x. I've got 2 minus 4 times negative 1. That makes it 2 plus 4 equals 6. And then, so 6 is your final answer. If I plug in a plus 7, here's where I plugged it in. Now I'm going to distribute, and I have 2a minus 4a minus 28. Be sure that minus distributes there. So then you have negative 28 and 2. So that will make that negative 26 minus 4a. Again, the domain, there's no restrictions on this. We can put in any number at all. It can be negative, positive, a 0. It'll still work. So all real numbers. All right, let's go to number 11. Number 11, our function is 3x minus 22 over x plus 6. Evaluate for x is negative 2 and for d. So for negative 2, and I'm going to scoot my thing over so we'll see. So if I put in negative 2, on top I ultimately get negative 28. On the bottom I get negative 2 plus 6, so I have 4. So the ultimate answer is negative 7. When I plug in d, I just put d everywhere there was an x, and I have 3d minus 22 over d plus 6. Now, we go to this last part that says the domain, and we have to think about it now. What if this denominator of the function ends up being 0? Well, then it would be undefined. So there are some restrictions on this one. If we move over, you take the bottom, the denominator, and set it equal to 0 to find out what your restriction is. D equals negative 6. So the domain is all numbers except negative 6. If I put negative 6 in there, then this goes to 0 on the bottom. So the domain is all real numbers except for x not equal to negative 6. All right, let's look at 12. On number 12, we're using a graph to figure out some things. All right. Find the domain and range of G. Okay, so some people look at this and they say, oh, this goes from -2 to 2. But what we have to remember is this parabola, as it goes down, it gets wider and wider and wider on both sides. So ultimately, for every x, there is a y. So the domain is all real numbers, and it says put it in interval notation. So we're going to put it like this. The range is restricted. It doesn't go any higher than 4. So from -infinity all the way up to 4, and that's how we'll write that, and we get a bracket because 4 can be included. All right, use the formula. Use the formula. Here's your formula in yellow to evaluate G of -1. Plug in -1 for x, you get 4 minus 2 times -1 squared. -1 squared is +1, 4 minus 2 is 2. So that would go there. Use the formula to evaluate G of +1. Well, we end up getting the same answer because when you squared this -1, we still got +1. So we have a 2 again. Then it says use the graph to evaluate. So we should get the same numbers. But let's see how we do that. If we go to -1, that's right here, -1, and we go up till we're sitting on the blue graph, that y value there is 2. If we do 1, we start here as an x, we go up until we're sitting on the blue graph, that's still 2. So our answers were correct, and we have the same thing both places. And that should be our problem set for 1.3. So now you should be prepared to go and do that homework. So if you have any questions, be sure to let me know.